Hey students, welcome back to my channel. Today we will be discussing about short answer questions from chapter 1 Rotational Dynamics. So let's get started. The first question we have is, if the ice on the polar caps of the earth melts, how will it affect the duration of the day? Explain. The answer for this question will be like, if the ice on the polar cap melts, the water spreads out toward the equator, right? And this redistribution of mass will increase the moment of inertia of Earth. According to the principle of conservation of angular momentum, if the moment of inertia increases, the angular velocity must decrease. That is, I omega equals to constant. And omega equals to 2 pi by t. On simplification, we can find out that I is directly proportional to t. And with increasing moment of inertia, the duration of the day will also increase. Next question we have, can you distinguish a raw egg and hard-boiled egg by spinning each one on the table? So answer for this question should be like yes, because a hard-boiled egg spins smoothly and fast because everything inside is solid and moves together as one rigid body. On the other hand, a raw egg wobbles and spins slowly because the liquid inside resists motion, causing internal friction and reducing effective angular velocity. Next question we have, experienced cooks can tell whether an egg is raw or hard-boiled by rolling it down a slope. How is this possible? What are they looking for? So answer for this question should be like, experienced cooks can differentiate between a raw and hard-boiled egg by observing their rolling motion down a slope. Because a raw egg contains liquid inside and its moment of inertia is greater than the moment of inertia of hard-boiled egg of the same mass. And when rolled down a slope, the raw egg will roll slower due to its higher moment of inertia, while the hard-boiled egg will roll faster. Cooks observe the speed and smoothness of the roll to determine if the egg is raw or hard-boiled. And according to the principle of conservation of linear momentum, we have I omega equals to constant and omega equals to 2 pi by t. And on simplification, we can find out that I is directly proportional to t. And since moment of inertia of raw egg is greater than the moment of inertia of hard-boiled egg, we can conclude that time taken by raw egg to roll down is greater than the time taken by hard-boiled egg. And hence, hard-boiled egg moves faster than the raw egg. Next question we have, both the work done by a force and the torque produced by a force are the product of force and position vector. How can one make difference between the two? Explain. For this, we know that work done is a dot product, or we can say it is a scalar product and is a scalar quantity. On the other hand, torque produced by force is a cross product, or we can say it is a vector product, and hence it is a vector quantity. This is the main difference between the work done by a force and the torque produced by a force. Next we have, if Earth shrinks, how will the duration of the day be affected? Shrinking of Earth means the decrease of the radius of the Earth. So if the Earth shrinks, its mass will remain same, but its radius will decrease. Since the moment of inertia is proportional to the square of the radius, that is I equals to mi square, the moment of inertia will also decrease. And according to the law of conservation of angular momentum, if the moment of inertia decreases, the angular velocity must increase to keep the angular momentum constant. And as the angular velocity increases, the time it takes for the Earth to complete one rotation will decrease, right? Therefore, if the Earth shrinks, the duration of the day will be shorter. Next question we have is, does the angular momentum of a body moving in a circular path change? Give an explanation for the answer. So the angular momentum of a body moving in a circular path remains constant if no external torque acts on it. Why? Because angular momentum is the product of the moment of inertia and angular velocity and is expressed as L equals to I omega. And for a body moving in a circular path at a constant speed and radius, both I and omega remains constant, assuming no external forces are influencing the motion. Therefore, their product, the angular momentum, also remains constant. But if an external torque is applied, it will cause a change in angular momentum. Next question we have, the cap of a bottle can be easily opened with the help of two fingers than with one finger. Why? So answer for this question should be like, using two fingers provides a larger lever arm and a greater applied force, making it easier to overcome the friction and open the bottle cap compared to using just one finger. The larger lever arm increases the torque, which is the rotational force, allowing for easier opening. Next question we have is, the work done by a force is the product of force and distance. The torque due to the force is the product of the force and distance. Does this mean that torque and work are equivalent? Explain. As we already know that work is a scalar quantity while the torque is vector quantity, and they have different physical meaning and units. Torque and work are not equivalent to each other. So our answer should be no. Question number 9, we have, a ballet dancer stretches her hands when she wants to come to rest. Why? This question is based on the principle of conservation of angular momentum. So when a ballet dancer stretches her arm, the moment of inertia increases, which decreases her angular velocity. And according to the law of conservation of angular momentum, if no external torque acts on the body, then angular momentum remains constant, allowing her to come to the rest more easily. Next question we have is, a flywheel rotates with constant angular velocity. Does a point on its rim have a tangential acceleration or a radial acceleration? Are these accelerations constant in magnitude or in direction? In each case, give the reasoning behind your answer. So since the flywheel rotates with constant angular velocity, its angular acceleration alpha is 0. This means that at equals to 0, so there is no tangential acceleration, we can say. Since the flywheel is rotating, a point on its rim is always changing direction. It experiences radial acceleration towards the center. This acceleration is non-zero and constant in magnitude because angular velocity is constant. Next question we have is, a fan with blades takes longer time to come to rest than without blades. Why? A fan with blades has a larger moment of inertia because the blades extend outward, increasing resistance to changes in motion. As a result, it takes longer to slow down and stop when the power is turned off. Without blades, the fan motor alone has much less moment of inertia and less air resistance. This means that there is less resistance to stopping, so it comes to rest much faster. Since the moment of inertia of a rotating object depends on the mass and how it is distributed, a fan with blades takes longer time to come to the rest than without blades. Next question we have, a solid sphere and the hollow cylinder of the same mass and same size is rolling down on an inclined plane from rest. Which one reaches the bottom first and why? So we know that the time taken to reach the bottom depends on the acceleration of object, which is influenced by their moment of inertia. Since acceleration of the sphere is greater than the acceleration of cylinder, the solid sphere has a greater acceleration and hence it will reach the bottom first because it has a smaller moment of inertia than the hollow cylinder. Next question we have is a ballet dancer can increase or decrease her spinning rate by using the principle of conservation of angular momentum, and how? So the answer for this question should be like, according to the principle of conservation of angular momentum, the product of the moment of inertia and angular velocity remains constant. That is I omega equals to constant. And when a ballet dancer pulls her arms in, her moment of inertia decreases, causing her angular velocity to increase. And conversely, when she stretches her arms out, her moment of inertia increases and her spinning rate decreases. Another question we have is, a ballet dancer stretches her arms to reduce her motion. Explain. So when the ballet dancer stretches her arm, the moment of inertia increases, which according to the principle of conservation of angular momentum decreases her angular velocity, thus reducing her motion. Next question we have is, a dancer girl is rotating over a turntable with her arms outstretched. If she lowers her arms, how does this affect her motion? Lowering her arms decreases her moment of inertia, and which by the principle of conservation of angular momentum increases her angular velocity, making her spin faster. Next question we have, explain why spokes are fitted in the cycle wheel. Spokes are fitted in the cycle wheel to increase the moment of inertia of the wheel. A higher moment of inertia makes it harder to change the wheel's rotation motion, providing stability and making it easier to maintain the balance. Next question we have is, what is the counterpart of the mass and force in rotational motion? The counterpart of mass in rotational motion is moment of inertia, and the counterpart of force is torque. Next question we have is, suppose that only two external forces act on a rigid body and the two forces are equal in magnitude but opposite in direction. Under what condition will the body rotate? So we know that for rotation to occur, the two forces must act in different points on the body and be applied in different direction, right? So if only two external forces act on a rigid body and the forces are equal in magnitude but opposite in direction, the body will rotate only if the two forces are not applied along the same line of action, so that they can create a torque, and that torque helps in rotation of the body to occur. Next question we have is, if the earth is struck by meteorites, the earth will slow down slightly, and why? So if the earth is struck by meteorites, the earth will slow down slightly because the meteorites increases the moment of inertia of the earth, and by the law of conservation of angular momentum, its angular velocity decreases, thus slowing down its rotation. Last question we have is, why is it easier to hold the 10 kg body in hand at the side than to hold it with the arm extended horizontally? It is easier to hold the 10 kg body at the side because the torque produced by the weight of the body is less in this position. And we know that torque is the product of force and the perpendicular distance from the axis of rotation, right? And when the arm is at the side, the distance from the shoulder joint is smaller compared to when the arm is extended horizontally. Therefore, less torque is produced, requiring less effort to hold the body. So this much for today. If you like this type of video, please comment down below so I can continue making this type of video. Till then, stay safe. Bye.